Let's get started. So today we're going to talk about graphing proportional relationships. And really our goal is that you can determine if the two quantities are proportional by graphing them on a coordinate plane. And really there's two things to think about. When we talked about proportional yesterday, or the other day, we talked that there were two conditions that had to be met. It had to go through the origin and have a constant rate of change. So really that's what we're looking at. This one's pretty easy to see in a graph. This one's going to look a little different, and we'll explore that today as we go through it. So let's take a look at this first problem. So the slowest mammal on Earth is the tree sloth. Yep. It moves at a rate of 6 feet per minute. That's really, really slow. So we can graph that because we have this idea. So the first thing we have to ask ourselves for this is it's proportional is does it go through the origin? So we ask ourselves questions like this. If there's no time elapsed, if it's 0 minutes, how far would the tree sloth have moved? And if you can answer, 0 feet. If it's no time, 0 feet, we know we're going through the origin. We get 0 minutes, 0 feet. Okay? Then we take a look at this next one. So it says the next day, after 1 minute, we know that he has gone at a rate of 6 feet per minute. So we go up 6. So we're going to have to kind of guess at this best point. We're going to say it's right here. At 2 minutes, he would have gone 12 feet. 3 minutes, 18 feet. 4 minutes, 24 feet. And 5 minutes, he would have gone 30 feet. Okay? So when I connect my lines, and I'm assuming I could draw this line perfectly, the second piece, that constant rate, you already know from looking at the word problem that it says 6 feet per minute. It doesn't change. So a constant rate has been found, so we know it's proportional. But on a graph, that looks like a straight line. Okay, so that's what we're looking at. So when I see it, I'm still starting at the origin, but now I'm going to have a straight line to have that proportional response. All right, go ahead and pause the video and decide if this one is proportional. All right, so you had a second to look at this one. You go, so this one's a little different. It doesn't have any numbers over here, so we're just going to say that each one of these is 20. So our scale is 20. Okay, this one we'll say is feet. This is time. This is minutes. Okay, so we'll make each one of these ones. So at 0 minutes, we know that it is currently at 140. So that's 20, 30, 20, 40, 60, 80, 100, 120, 140. So right here. It descends 20 feet per minute. So at 1 minute, it's at 120, and so on down the line. Now the question we ask ourselves at 7, it's at 0, does it go through the origin? Because it does make a straight line, right? So we can agree that this is a straight line. It's a constant rate of change. It is dropping 20 feet per minute. But it does not begin at the origin. So you're going to say, no, this one is not proportional. Okay? And really what that means is it starts at another other than 0. So it starts at another other than 0, 0. Okay. So let's take a look at this cost of renting video games from Games Inc. is shown on the table. Determine whether this cost is proportional based on the number of games rented by graphing this on a coordinate plane. So again, we're going to say this side. We'll say this is our games over here is down here. So that's our games because that's our X. That's what causes the cost to change. Here's cost. So if you rent 0 games, you're going to spend $3. 1 game you rent $5. 2 games $7. 3 games $9. Again, do we meet that constant rate of change? Yeah, this is plus 2 every time. But the problem is it doesn't start at 0. You've got to start ahead of time, so this is not proportional. And that's what we're going to say. Since it does not start at 0, it's not proportional because it does not start at the 0, 0 at the origin. IONAO. Okay? All right, you guys try to figure out this one. Is it rotational here? Is this one a constant rate of change? Is this one a proportional rotation by graphing this? All right, so let's put this on the graph. This time, look, do we start at 0, 0? Yes. If there's no time elapsed, it has not started to spin. After 5 minutes or seconds, it doesn't really matter, it says seconds here, so we're going to say this is. So after 5 seconds, okay, let's say that each one of these stands for 5, just to make our math easier. It's gone 2. After 10 seconds, it's gone 7. After 15 seconds, it's all the way up here, it's at 15. So my question, is this a constant rate of change? And the answer is no. It does do the origin again, that's perfectly fine. So, but it does not have a straight line this time, because the rate of change right here that I've circled is less than the rate of change in all the others. Okay, so it's non-proportional because it does not stay at a constant rate of change in this first location. It takes a few seconds to speed up and get it going. That's my assumption. Okay, we're going to skip these two. So really that covers all your proportional conversations. If you have questions, please reach out and I'd be happy to help you.